I see there's some people, I'll just briefly go over some new performance results I've gotten from subfiling on Perlmutter. There was an issue with Perlmutter before that they didn't want us running on it with subfiling because it was crashing the system. So they fixed that with a patch to the Lustre system. So let me share. Now I got some new results. So the first result is just with IOR with subfiling. And this writes between 4 and 8 terabytes. So it does weak scaling up. And you can see that, so I started at 16,000 ranks to 32,000 ranks, and it was using 128 cores per node. That's what you can run on Perlmutter without it doing hyper-threading. And you can see that the blue is in with independent. For some reason on Perlmutter, collective is pretty slow using this. So I didn't run it at this, I didn't run collective at this scale. So the blue is independent and the green is subfiling. And I ran it 5 times. So the bars are the range that the write bandwidth was. So it's pretty good. Even I'm surprised that the independent does so good as well at these scales. At some point, we expect the independent to start to nosedive. So I have jobs at 100K ranks, which should see if independent still is as good or not. I mean, relatively, it's okay. It's around 200 gigabytes per second, and the machine's theoretical is 5 terabytes per second. So we're quite a bit off of that, but that's for the whole machine probably. So that's all I have for just an update on the subfiling performance. So this is a new machine. And so I'll just stop sharing. And if you have any questions, I can.
How many files did you use for these runs?
One subfile per node.
Okay.
So that would have been 512.
Mm-hmm.
I haven't played around with that yet. I can also do more subfiles per node. I can also increase, and I didn't do alignment. So currently the file is not aligned with the Lustre, so that might help as well. By alignment, I mean how many bytes you write per subfile before going on to the next subfile. Usually that helps to align that number with the alignment in the file. So for the bigger run, I turned that on. So we'll see what happens. I also increased the number of OSTs. So Perlmutter has, for the stripe size for the Lustre, it has 274. So I doing it in multiples, so I can use 256 at that scale of the OSTs on Lustre. So that should help too. Before I was just running with 96. So we'll see how that works.
Mm-hmm.
Any questions? Marta, I'm sure you have a question. Or am I wrong?
No, not today, not today. But
Oh,
thank you for
don't?
sharing.
Okay.
That is useful.
How is your work going?
I had to move into an ALCC proposal and also an ESP project, so it was kind of stuck, but I'm still interested.
Okay.
The insight that will need this was recently approved for awarded the 2023 allocation, so we should be able to talk with them soon for the welcome call. So I hope that we'll be able to recover that interest in the subfiling and other options for their HDF5 file transfer and IO.
Okay, so you haven't gone back to, you didn't finish your implementation?
No.
Okay. Yeah, let us know if you need any further assistance when you get back to it.
Yeah, they have Theta and Polaris for next year. So I don't know if that will make a difference in subfiling.
Yeah, and actually, Jordan, who also is working on that project, is working on Polaris. He said that they now have the SSDs attached to Polaris. So I have jobs now running that are going to do subfiling to the local loads, the local storage on the nodes to see if that helps performance. So I should have that by probably the next the next time I host this.
That's good to know,
document.
because for another project, I play a little bit with the SSDs, but it was not making any impact on that particular example that I had. But I can run the SSDs on Theta, so I could do this. I could test that too in both machines also.
Yeah, we'll see what that, it should make it go a lot faster, but then you have to drain it to the file system eventually. But at least for the writing, if you're not planning to persist it to disk for baby visualization, or I also want to try draining it from in the background to the file system as the job is still running from the local nodes. So you can fuse it back together. We'll see how that works.
I saw on the banner it said there was something about Fortran and async. Has that happened already, or?
No, I'm in the process. I have the async, all the async wrappers for Fortran done, but there are no tests in our library for async. So, and the only tests that there are is in the vol async. That's the only way our async APIs are getting tested. So I'm adding it to our testing framework. So I don't have to, I didn't want to add Fortran to the async vol. So I'm adding the test within our framework. I'm writing it now. There's a few things I guess, well, I'll just talk about this real quick. So Dana, do you understand what op counter means? I don't really understand what that function does.
Oh, I'd have to go look and see kind of what that stuff is doing. I've left most of that discussion to Neil and Jordan. I've been kind of staying out of it while I've been doing some other stuff, but I can go take a look. Do you think it's possible for?
Sorry.
Oh, do you think it's possible for testing the async connections? I mean, do we need like a separate repository that we could pull in the async vol and the native library and then try to write some async Fortran tests?
Yeah, but it's probably just easier just to, I mean, I skipped the test if the vol is not enabled. So it doesn't do anything. It will only test it if the vol is available. So it has to be available, I guess, in one sense, or it won't test it.
Okay.
But yeah, I just didn't want to do the, add that CMake stuff and all. I didn't want to add it Fortran to their testing.
Right.
Because it's really not set up for that. Whereas ours is already set up for the wrappers.
Right.
Yeah,
as for like all the counts and stuff like that and maintaining it, I don't know. I'd have to go look at this stuff. I didn't really assist much with the creation of the async vol.
This is weird because it says, so this is for the H5ES get op counter. It says retrieves the next operation counter to be assigned in an event set. So operation counter means what?
I have no idea.
I don't either.
Yeah, I have to go look. That was all developed by people who are not me. But I was planning on going and taking a look at it because you brought up some stuff about the types where there was some type mismatch.
Unless counter is I don't know. Yeah. I just don't know why you would choose an N64 over just size T if they're measuring the same thing, but then maybe they're not.
Yeah. I mean, in general, I've been less of a fan of the magic types that can have various sizes. That if we really want things to be as big as possible, then we should use large types. But I have no idea if like size T was picked because it matches to some like memory allocated thing. I don't know. We have to go look. I mean, sometimes like these things wind up in the API and they were just convenience choices.
Yeah, it's always a mystery.
Yeah, but we should take a look.
When they pick a general size T or something, SS size T, or they actually specify that it's the N64.
Right. Yeah, I feel like, when I was looking inside the library and fixing the remaining warning issues, this is something that I've wanted to do, is to generate a, in the doc directory, have an integer type guide for HDF5 that, we're we're a library that's designed to be used at exascale. So we do care about the extreme ends of stuff. We don't, like, our integers are not always just going to be like 6 or 10, right? They're going to be billions and billions. So I feel like a lot of the casting issues that we have inside the library that generated warnings were due to people just kind of glibly picking like, oh, long or oh, int. And then
Yes.
they mismatch to the things that are very specific that come from the file, because stuff that comes from the file is usually like, you know, we know that this field on the file is 32 bits or 64 bits. And so we pull it into that, and then we get this mismatch between the API where we're just kind of doing arbitrary things and then the stuff that came off the disk. And we need to, the whole library should be architected so that it reflects disk things, because that's what it is. It's an IO library. And I feel like that's one of those things for HDF5 2.0 we should start paying a little more attention to.
Yeah, and for 2.0, we should definitely add in overflow detection for Fortran, since Fortran doesn't have an unsigned int, and we pass it a lot of times either back and forth to an unsigned int in C, that's not really detectable right now.
So how do Fortran people deal with, like, if you have an unsigned int64, is there like an in Fortran, is there a 128-bit int type in the standard, or no?
Yes, you can. There's this an integer 16 byte.
Okay, so that's what they do, is they basically just like put that inside a really big thing.
Yeah, make it bigger.
Ah, okay.
But it's always signed, so they always have to have
Right.
it signed.
Yeah, Java is the same way. But I don't think Java has, I think once you get above 64-bit integers, I don't think they have 128-bit. I think after that you have to put it into like a big int. I may be wrong though. It's been a long time since I've coded in Java.
But that also assumes that, well, I guess C long int, is that always guaranteed to be 128? It isn't, is it?
No. The long is 64 usually, right? Because there's like the different 64-bit programming models. Like it's ILP, LP, and P64, right? Depending on like what you have, right? And I think that like which ones are which, I always forget. I always have to go look. Let's see, 64-bit computing. There's a Wikipedia has a handy link for that little table. I always forget. So yeah, so Windows is LLP64. So long is 64-bit, and pointers are 64-bit on 64-bit Windows. And then Unix systems are LP. So longs are 64 bits, because on Windows longs are 32.
Oh.
Yeah. So there's like this is the thing I always go look at. You scroll down, put it in the chat. It's a very nice table. Because they mention a lot of like crazy stuff too, right? There's SILP. There's like a classic Unicode system there. Everything was just 64-bit. And Spark 64, ints were 64 bits. Lots of fun if you're interested in computer archaeology.
Yeah,
I guess I always wondered about like how we deal with that, like when the programming language doesn't match the HDF, the richness of the HDF5 type system. Like, what are all the language workarounds that we do to make stuff fit?
I mean, it is theoretical that you could write a file in C that couldn't be read back in Fortran just because it might overflow the ints, right?
Right. Same thing with Java.
So Marta, do you see a lot of programs in Fortran still at the labs, or is it all mostly C++?
We still see Fortran. In fact, it has been a requirement, let's say, so for Aurora still make sure that the Fortran compilers are operational. Obviously, we see more C++, but you can still see MPIF77. We need to check on all of the glories. Yeah.
I see.
Yeah,
So,
when I see like programming language lists, I'm always surprised to see that Fortran is higher than I would have expected. So if, like, in terms of popularity and repositories and, you know, however they're measuring it, the Fortran still has quite an audience.
So it's a dependency on Aurora still. That's good, I guess.
Yes, because by default, the inertia to change in scientists is high. So you want the results, and sometimes adapting to the new machines is a lot of effort. So at least you want to make sure that whatever is the language that you're using is the same. And you don't put efforts potentially in that if you don't have a big grant. So it's difficult to get a big transition. I'm taking out Fortran into C or C++, except you have projects like the ECP, where you have several millions of dollars and you can accommodate this kind of research. Otherwise, it goes slowly, in the sense that, oh, you have features that you may need from C++ or C that are interested, then you potentially start the conversion. Or you have deprecated features that are not working anymore with the compiler, then you are forced to change. Or you have issues with building and linking that are also forcing you to change. For example, in another code, the one that I'm interested in testing for this insight is for NACS. They used to have some Fortran codes and they slowly changed because that was into C, because that was an issue every time with the C bindings or something like that. So they were having problems, and because it was like 4 files or 5 files, it was easy transition. But when you have a big number, it gets more complicated to find someone who has the time to debug and test that everything is still operational at the level that you want.
Right.
When people write Fortran programs, these or Fortran software these days, how much do they use the newer language features?
It depends. Is that, I don't know if it's a question of me, but at least from my side, there are some that if they are real experts on their code that they want to get the maximum, they try to follow what is new and how much they are gaining. So we have codes that require, I mean, maybe just the recent Fortran capabilities, but sometimes because of the compilers don't adapt too fast or as fast as the language should, they are delay a little bit on that. For Fortran, we had to push a little bit relative to Aurora to make sure that the integral compilers were operational and that everything was working fine. So that was a side strive for, but at least a minimum of functionality and slowly asking for what is missing. It's like you developing new features. You have to see a user or find a user. So if no one asks for that, at a certain moment it will deprecate. But same thing, if they don't ask for a feature and it's not available, then probably they won't be able to get it into the new compiler or back, or even an issue request, a PR request. So it takes time, but there are those who are still believing in Fortran for HPC.
Okay.
And Cray is just basically the PGI compiler, right, for Fortran. I think that's what they're using.
Do people generally feel that there's a big difference between compilers in terms of how efficient of code they generate?
Probably. I think Fortran programmers always assume that their code is faster in Fortran than the C or something. I don't know. You always get, I don't know.
But I mean, across like Fortran compilers, right? Like, I mean, I know like for a long time, until GCC got a lot more attention recently, like in the past, GCC was known to be a slower compiler than a lot of the like vendor specific ones back in the day. right? And it was because GCC had a really complicated back end. And so it was difficult to do optimizations. And that's kind of like why they've had like so many warning changes over the years, is that they're trying to get people to write better code so they can, as they've improved the back end, they can check for things. But like for a long time, people would advise you that if you're writing real performance code that you should compile with, if you're building on Sun, you should compile with Sun's compiler, or building on like IRIX, you should compile with like SGI's compiler. And I think that may be less true today, that like it doesn't really matter if like you have Clang or GCC. Maybe I'm wrong. Do people think that like Clang is like significantly like better than GCC? Or
In the past, it was because those compilers they went directly from Fortran to assembly. There wasn't, and GCC, I think, had an intermediate where they went through the C library or their C compiler. So they just it's not a native in the sense that it goes directly from Fortran to assembly. Where I think GNU, I think they still do this, that it goes through their C compiler to Fortran. It's not, it doesn't go directly. That's why it's a little slower. At least it has been in the past. I'm pretty sure. So when we do bug reports, it always seems to be with the C part that they're passing from Fortran. So I think it's still the case.
Interesting.
Yeah, from my side, I don't know, I think from my side, at least with respect to what we see on the facilities like the LCF, it depends on the complexity of the code on one side, because if you have a lot of dependencies, sometimes you use what is available. So you don't have too much opportunity to play around, because we may not provide all the options for everything or the modules. If you have time, then you can play a little bit, but at least, for example, with Aurora, obviously the machine is focused on getting ICX and ICPX for C and C++. Well, then those who have also Fortran subroutines, they are going to use IFX as a compiler. For the codes that I'm helping, it's a different thing in the sense that we want portability. So then if we go to a different system like the NVIDIA GPUs or the AMD GPUs, we are going to try to use, at least with OpenMP Target, the LLVM compiler. But from our users, it depends on how many people do they have to test and play around, how complex is the code, and if the models are available or they have to build them themselves. What is their experience in other facilities? Because sometimes what they do is just copy paste the scripts that they have used, and they just tweak them a little bit. But it's, I don't know if one size fits all. What I know, at least from experience, because of one of the projects recently, we are trying. We were trying to catch up on 4 years of missing Coco's upgrades, and we noticed that with one of the modules of CUDA, we were having issues in the version, because that version was it was showing a particular bug, which was making no sense, but it was related to the compiler. So we were able to track and figure out that different versions were working and which were not working. So we were forced to move to a higher version because that bug seemed to be fixed in there. But we didn't have the opportunity to check on performance. It was mainly, first we need functionality. Is it working? If it works, in general, you don't touch, or at least you get results, and then you have time, you check other options. But that's a good point. Eventually, where we see difference in performance is if you are doing JIT compilation just in time versus ahead of time, depending on the compiler. And then if you are fast compiling, you are slower running. So it depends on what you are doing. If you develop, you want to be fast compiling, and then you want to run and don't develop, just run. You want to have the slow compilation and then run as fast as you can. Yeah, that is a good thing that we could test.
And we never really seen that great improvement optimizing compiler for HDF5 itself, because it doesn't do a lot of computation. I don't think it really helps. At least I haven't noticed. Between production and debug, it's, I'm using 0.0 or 0.3. I don't think it really matters that much.
Yeah, I think in terms of, when you build a debug version of the library, in terms of how it's going to perform, the only thing that I would say that the thing that probably makes the biggest difference is not the optimization level. It's when we build the debug version of the library, there's a bunch of extra checks that we do that would just go away, right?
Mhm.
Some of those are just asserts, and that's not really a lot of computation. But there are checking routines that do more complicated stuff where we've surrounded it with, if def, H5D debug or something like that. And then that actually does some extra sanity checking. And some of those can get computationally complex enough to the point where we don't build them by default. Like the B tree ones, for example, are not turned on by default because they take forever to run. So there are things that I think are a little bit slower, but it not in the way that gets in the way of a lot of the IO. So if you're really dominated by writing to a data set, you're not going to see a lot of changes, I think. Because I mean, the only places where I think that optimization changes stuff under the hood is where we do type conversion, because that's also where we get bugs. In the past, we've had issues with having very high optimization levels in some of the type conversion code. But other than that, I think we don't really, maybe some of the data space code.
I can see DT arith because it might make some optimizations that affect the round off.
Right. Yeah. There's a bunch of places in there where if in the past, I mean, most of them have been fixed, and some of them were due to problems that we had actually inside the library that we've subsequently fixed. But I remember there used to be problems with Mac OS used to have a couple of long-standing bugs. Solaris had a couple of long-standing bugs. There used to be a whole bunch of workarounds in the configure layer for working around those things, and we got rid of most of it because it wasn't necessary anymore.
It does seem it's converging, at least at HPC. There's not the wide spectrum of companies anymore
Right. Everything is just
that there used to be in the
on
past.
Intel or ARM.
Yeah.
Although, I feel like, I mean, there have been some things that have shown up that we have. There's a bug in HDF4 from M1 silicon. So I feel like, maybe everything seemed to be converging to Intel for a long time, and now it seems like things might be expanding a little bit because ARM is popular, and that's what RISC-V, right? So there's potentially other stuff where it'll become more heterogeneous again, but not like in the past, not like in the late 90s where there were like 10 different chip makers that were big.
I guess that's all I have. I think we're a little over time.
Any other questions?
Yeah, so I should have more results by the next time I post this on Subfiling, hopefully on Polaris. We'll see what happens.